Okay, let's add some blocks to the screen so that we can start playing our game. First thing we're going to do is create an array. That's how we're going to keep track of all these. So G rectangle, and remember these brackets are the signal for an array. We're going to call it row 1. We're only going to add one row of this, of bricks, but you'll be able to copy this line and the way in which we instantiate it and just add more if you want. So that's going to be equal to new grect, and we're going to have 7 bricks in it. That's about how wide it'll work for the size I have planned. Now just to review this, that's the name of our variable, which is an array of variables. The type is going to be G rectangles. You can have integers, doubles, strings, that sort of thing. And it's set up to be a new G rectangle with 7 of them. This reserves the memory, new, and this is saying how many of these objects or items we're going to have. So we have 7 of them. So we also need a constructor to put these together. So that's going to be public blocks, just the same as the name of the class we're in. And rather than add them all one by one, we're going to use a for loop for this. For loops are very handy because we know how many we want. We want 7. So we're going to do something like this. For, I'm going to create an integer called count. Just keep count of how many times we go through our loop. So while count is 0, we're having it start at 0. And while count is less than 7, because remember, these count arrays, when you count the number of items in there, they count starting 0, 1, 2, 3, 4, 5, 6. That's how we get 7. So that's why we want to end before we hit 7, or we'll have an out of bounds issue. And then we can add 1 every time through our loop. So these are pretty slick once you know how to use them. And we're going to need another set of curly braces. So what we're going to do, we're going to do row 1, and we're going to use the variable count in there. So the first one is going to be the 0th item in our array. Second time through it'll be item 1, third time item 2 is equal to a new G rectangle. And I'm going to have it be 75 wide, that's the X, and 20 high. And then let's set it, we'll set it to a nice color, maybe blue. And that's all in caps. And remember, if you want to use colors, you're going to need java.auth, the Abstract Windows Toolkit. And then we'll make sure it's filled. So what's nice about this so far is that we're going to fill our array of 7 items just by looping through 7 times. We could copy this and paste it 6 more times and change this to 0, the next one 1, 2, 3, 4, 5, 6. But this is far, far easier. So that's the advantage of arrays. I'm going to compile that, make sure I don't have any issues. And I do. Incompatible types. Let's come back to that a little bit later. Because first we want to add these to our screen. So we're going to add, oops, that might be the issue. I'm going to add row 1 to the screen. But I'm just going to have it do it as we make them, and we add them. And we'll put it in at this location. And the Y location is going to be 0 because they're all going to be on the same. All right, let's compile this, and I'll probably have to put in an x variable because I don't seem to have that. So we'll go with integer x equals 15, 30, wherever you want to place them towards the top. Okay, it's Friday afternoon, sorry about that. So I was missing the object.method syntax. So I have to do row 1 dot set color. So compile. And we're going to need to add these as well. So we have add blocks. Let's see if that works already. So we had a blank method there before. All right, we got one so far. Now what's probably happening is I have them all at the same x location, so I'm going to need to space them out. If I go back here, let's see, the width is 75. So if I keep putting them all at the x location, I'm going to need to scoot them over. So I'm going to do x equals x plus, give them a little spacing, maybe 80 pixels apart. Let's see if that'll work. There we go. So now we have some. And I might scoot them a little farther down. So 20 is the width. So let's put them down maybe 30. There. Now we're sitting pretty. So the next thing we have to do is check for collision with the ball and the bricks. Now to do that, let's add another method here. Ball dot test for collision, we'll call it. It's going to be very similar to the ball bounce, except when we hit a brick, not only are we going to be bouncing back, but we're going to remove the brick. So I'm going to copy this name, go back over to ball. We got ball.bounce. I'm going to move this up here just to make it easier for you to see. And we'll do public void test for collision. Compile that, even though it's empty. Go back here, compile that. All is working. Okay, so let's update our ball test for collision method. First thing we'll probably need to do is get the ball's location. So we'll do what x is equal to ball dot get x, and y is equal to ball dot get y. Now notice I use some variables that were already declared up here. So I want to make sure they're not being used. So it looks like they are, but they're being used for the same thing. If we would declare something like integer c here, that'd be a local variable, local just for this test collision method. So we wouldn't have to worry about something down here using integer c. I could have integer c declared down here, and in past programs that would cause a problem of having something that's already declared. But local ones don't share outside of the scope of their curly braces. But since we have x and y declared up top, these are local, global variables, so they're shared by everything. But since they're achieving the same purpose and getting the same values, shouldn't be a problem whatsoever. So if they collide, we're going to have to move the ball. So we'll do something like ball.move, and we have mx and my. And since the ball will be traveling towards the top, which is negative direction, what we can do is just turn them to a positive direction. to get it coming back down. So we can use these default values. Let's compile that. Now the only thing we need to do is get the information on the bricks. So we're moving the ball, but we have to somehow test to see if it is colliding. So we have no methods in the block area that does that. So we're going to have to create something that, so we know whether or not we're near the brick's location or the block's location. So we'll do something like blocks.get row location. See if we're hitting them. And we'll have to go over here and create that so that we don't get an error. I'll compile that. And we'll go back here, compile that, and fix any errors that we might have. And the first error we're getting is that we can't find the symbol blocks. So somehow we're going to have to get that information. We're going to have to pass an object over here. Now the way to do that is to find where our blocks is created. Where is that object? Well, that object is back here. We created blocks right here in our breakout class. So what we can do is when we call our test for collision method, we can pass over blocks. And we have to define the type here so it knows what it's receiving. So let's compile that, and then check and see where our errors are. All right, so get row location. So let's take a look at this error. Get row location, illegal start. Okay, it looks like I still have it in the constructor. So I was one curly brace too far. Okay, compile that. And back here. And just to be sure, I'll compile that one. Okay, and one of the challenges is going to be is that we're testing for a collision against an array. So let's go back to our new method, get row location. So as we test for collision, we're going to use the same for loop in order to get to cycle through our entire array. So let me copy that. This will allow us to cycle through 7 times to check for each one, and the computer works so quickly that it's not hard work for the computer. So we can do something like A is equal to row 1. And I'm going to copy that, count. Dot get x. And B is equal to A plus 75 is I think how wide they are. This way we have both the left side and the right side of the block accounted for. And I'm going to declare those variables. And then we're going to use our similar if statements for when we were checking for collision with the ball. So I'm going to throw something like this in there, copying that out of ball. So in this case, the first thing we're going to check with is the Y location. So if the ball Y location is less than, let's say, where did we put these? X is 30, so they're at 30. So if the ball is less than less than or equal to 30. Then we know the ball's high enough to impact the blocks. Then we have our nested statement to make sure that it's between A and B. So if the ball's X is located, it's greater than A, which is the left side of the brick, and the right side, then it looks like we're just going to simply reverse this location. So I'm going to compile this. And we're going to get some errors because there's some information we don't have. Well, first let me clean up these errors. Looked like I was missing one. Okay. So we can't find a bunch of these symbols, the X and Y. So we're going to have to pass these things over because we need the location of the ball. So we're going to go back to the ball. And we're going to send over X and Y, I believe. So we need the balls X and Y. Remember, when you're passing multiple parameters, the location is very important. And while we're over there, we're also going to reverse my. So it needs to know what my is. So let's go back to blocks, and we're going to have to receive these. So we're going to have, I think it's double X, double Y, and double my, I think is what we sent over. Yes. Now, since we're going to reverse this, we're going to need to send it back. So we want to do a return statement. So remember, methods can do calculations for you and then return a value. But since we're returning a double, we have to turn this into a double because that means it will require a double to be returned. Void meant we weren't returning anything. And it looks like my return statement isn't in the closing bracket. So it needs to be right before the closing bracket. And one more. Got a lot of curly braces here. Okay. That's why you want to have nice and organized curly braces, which I currently really don't. So if we're going to return my, which is the ball's y speed, we're going to need to be prepared to receive that. So we're calling that right here. We need to store that in my. Let's see if that works. Let me go back and compile that. And compile that. So now, when we call this method, we're going to get back a new value for this. So if the ball is going up, it'll go that way. Also, if we hit a ball from the top, it'll bounce back up. So sometimes in Breakout, you can break through and you can bounce along up top and really remove a lot. So that'll give us that ability that no matter where we are, it's going to bounce us back. So let's try this out. There we go. Now notice it's bouncing off the top wall of the bricks. That's because the X and Y, the X value is generally considered the top. So we're going to have to do X plus 20 to get to the bottom of that. So we should be able to find that in our test for collision method, which calls on get row location. And we will do a get y comparison. So if y is less than or equal to 50, and that should do it. All right, that's it for this episode.